So good morning, everyone. Thank you, first of all, again, for this opportunity to participate in this Robarts conference. It really is a delight and a privilege. So my name's Ituen. I'm from York University, and today I want to discuss my research in the context of the crisis, the challenge, and the changes occurring in Canada. The title of my research today that I'm presenting is Estimating Land Cover Change and Greenhouse Gas Emissions Using Spatiotemporal MODIS Data. And I'm drawing on a case study in Northern Ontario. So let me introduce you first of all to the area that I'm doing my research in. This part is called the Ontario's Great Clay Belt area, and you can see it over here in northeastern Ontario. Geographically, it does extend actually from Quebec all the way into Ontario, having an area of about 180,000 square kilometers. But just the Ontario portion that we can see here, the Ontario portion actually is much smaller, not too much smaller, but it is smaller. It's about 120,000 square kilometers. And just to give some perspective, the entire area of the Great Clay Belt area in Ontario is equal to the farmed land in the whole of the province. And 70% of it is actually forested. The area has been dubbed the Great Clay Belt area for a reason because of the type of sand or soil that's typically there. So it's predominantly clay soil. And if you know anything about clay, of course, it's not very easy to manage or maneuver. However, one thing is that it is pretty rich up there in the Great Clay Belt area, and it is fertile. Right. So why don't I take you a little bit on a bit of history in the area. So remember 1919 was just after the Great War, the First World War. And after that, the provincial government wanted to repopulate or populate that area. And so what they did was they made a call out to the soldiers who'd returned from war. And they said, hey, come over to this place that we're calling New Ontario. And they said that anybody who's of good health, has ordinary business ability, has determination and strength would be able to succeed in the place. And to sweeten the deal, they offered a parcel of free lands to people that would come. And so if you would come and you want to be a farmer there for your next career, they said, well, you can grow alfalfa, clover, field roots, barley, other grains, and such things with phenomenal success. Now, one thing that stood out to me from that call out that was made, the advertisement, was that they said that there are no stones there and there's good drainage. And, that struck me because I do know that the area of the clay belt does have a poor soil drainage. Another thing that was in the advertisements was that the winter months were sometimes a notch lower than Ottawa or Montreal. And that also did strike me as being something because of what we know about the temperatures in that place. All right, so just to give a little bit of context, the average temperature in July in the Clay Belt region is about 17 degrees Celsius. As well, the peak mean monthly rainfall in that month is the same, it's about 95 millimeters. So we do know the weather is quite different. I mean, the winters, we can imagine the temperatures that would be. And as an example, they only have 95 frost-free days in the entire year. For instance, the last spring frost occurs in June, and typically you would have the early frost for the fall occurring in mid-September. And one would think, well, those aren't really ideal conditions for crop farming. But let's see what happened to those people from 1919. What were the results? Unfortunately, they were met with failure. So a lot of these soldiers had gone over, heeded what the provincial government had offered, but they weren't able to meet or to get what they expected to get from what the government had said. And so an inquiry was set up in 1920, a commission of inquiry from Kapuskasing Colony. And what were some of the conclusions that came out of it? The first one was that the conditions were way too harsh. Another conclusion that came out from the inquiry, report of inquiry, was that the government had overpromised to the soldiers on the ease with which they would be able to have success. And so following all this, they decided, well, what should some of the remedies be? And the first one was that they offered a refund to all these soldiers who had come to try to be farmers. And they said, well, we can give you a refund on the land and on the animals for which you've spent money in trying to cultivate the area. Finally, they also offered free transportation to these soldiers as well as to their families to any other place in Ontario. And so this was the story that happened about a century ago when people were trying to farm in the area. But really, what is the potential of this area? What really happens in this area? Why did they meet such failure? Well, for one thing, the terrain really is difficult. You might have known about it, or you might have heard about how Northern Ontario. First of all, it is true the weather in winter is pretty harsh. As well, the infrastructure is not as much there in terms of what we might experience in Southern Ontario, where you have ease of taking goods from where you are to market. So the road network as well as the infrastructure. And also even just traversing the area in terms of getting to the hubs for where you can be able to load off your products and distribute. But there's another story as well. So a census was done a few years ago, about 2016, 2017. So in that last census that we saw, we can say that in the whole of Northern Ontario, actually, there are at least 2,000 farms, and they actually did produce about $203 million worth of agriculture receipts. As well, in that area, we do find that there were over 633,000 farms in Northern Ontario. So there is potential. There are people who are trying to be farmers there and are having some level of success. And as well, they do grow some crops there. And now I want to bring you back present day. So the Ontario Ministry of Agriculture, Food and Rural Affairs has decided, we want to try again and develop this part of Northern Ontario. So specifically the area where I'm looking at in the Great Clay Belt. And right now the government has made a proposal and is being looked into for about 3 years now to attract livestock farmers. And the project is called the Northern Livestock Pilot Project. So there are some incentives, but it's not like what we had a century ago where there was free land, but there are some incentives to people who do want to come and participate and become farmers there. And we do hope this time it's going to have a better outcome. But what are some things that we can say will be different between what happens now and what happened in 1919? Well, for the first thing, we do have the advantage of advanced technology. For instance, in the area now, there is a lot of mechanized dairy farms. As well, you would also find that tile drainage is also available. So that is one of the things that hindered the farming there, was the accessibility to some of these advanced technologies that they could use. And so if we do have things like this, well, what will be the impact of those? Well, we can see that if you have farmers that are going to be using advanced technology, then it's more likely that they are going to be able to succeed. And so the provincial government has recognized that with these, that they can make a call out to people, and we hope that there would be better success in the area. As well, there is a lot of forestry that goes on, so there's logging, and so there is an industry already, and there are routes and channels for farmers to deliver their products to market, and so that also will be leveraged in terms of what they're going to continue to do. Another part of the technology also is the greenhouses. And so because of the climate that's there is an abundance, I would say, of greenhouses that are being used, and they're relatively well priced. And so they can be used to protect your crops against the early spring early fall frost or a surprise spring frost. The funny thing right now is that for the clay belts, there's only about 1.4% of the area that has actually been developed for farmland or agriculture, so livestock farming or crop farming. However, the Canada Land Inventory looked at it some years ago, and they did see that there's about 4.4 million acres of land that's actually suitable to be used as agricultural land. And so the question arises, why out of that is only 1.4% that's viable being used for farmland? And the answer is really twofold. The first thing is the drainage. So in the clay belt, like I said before, the soil is clayey. It's really compact. I had the privilege of working there for a little bit. The soil is really compact, and so it's not easy to manage. But what happens with the drainage is that the water really normally just stays on top of the soil. It doesn't drain properly. But again, with the technology right now, so those two things that keep people away were the poor drainage and the climate. And with the drainage, there is something called tile drainage. And so a lot of farmers have invested in that right now in the clay belt, and they're using tile drainage, and that allows the air to drain down, the water to drain and allows air to get into the soil. The next thing as well was the climate. So the climate really, what can you do to solve it? You can only manage it. But that's the other thing that also hinders people from becoming farmers or from to access the farmland that's available there. And like we can see about 14 rain days a month in the clay belt. So you would say, well, those aren't really good conditions for crop growing. However, they have been able to grow barley, wheat, and oats usually there. But this is something that's happened in the last few years. So there has actually been a long-term climate warming that has been experienced. And the annual crop heat units have actually risen by about 25%. And this has had a very positive effect on crop production. So what does it mean? That means that they've been able to experience greater yield from their crops. And another thing is that they're actually able to introduce more crops and plant them successfully. For instance, now they're able to plant things like soybeans and corn grain and silage corn, which before that was not a possibility. And another thing that they're also able to do also is to have livestock. So the ruminant animals the land will support large herds of ruminant animals there. And so that's one of the things that has been happening. And so with this pilot project, they're thinking of, the government is actually trying to bring people in to continue with livestock farming as well. But all that to say that there is a positive effect from climate change. Okay, so we now see that with the climate getting warmer, we have an extension to the growing season. The extension to the growing season also, we're able to introduce new crops. And so there actually is an increase in the economic viability of farming in the area. So I'd like to say it's a positive effect from climate change. So recognizing this, the provincial government does want to take advantage of it and wants to bring people in and say, well, why don't you continue to do farming, get assistance from the government, and just have that initiative to convert a lot of the forested land to farmland. So remember, I said about 70% of the area is forested. So the plan is to convert some of that forested land to farmland, so either cropland or livestock, and have that development occur, since the technology is available to be productive and to be economically viable when the conversion is made. And actually, that really is the thrust of my research. So we'll have all this forested land that's going to be converted to farmland, and what will be the impacts of these? So my research is just looking at the environmental impacts of the conversion of one type of land use to another type. And specifically, a lot of it will be from forested land to farmland or to agricultural land. And so what will happen from there when this conversion is made to pasture land or cropland or what have you? The expectation is that there will be changes chemically in the atmosphere and in the soil. And I want to be able to estimate how much that is. And so first of all, what I have done is to determine the land cover changes. First of all, what we will do, of course, is to establish what is already there. And of course, because the clay belt is so vast, it's impossible to map what these things will be, what the land use is, by doing field visits. And so that's why I would be using Earth observation satellites, which are able to monitor the Earth and tell us exactly what is on the ground. And so the first tool I've used in my research is this moderate resolution imaging spectroradiometer, the MODIS. And its moderate resolution is so good that I can use it for the large scale monitoring. It's actually quite suitable and adapted to things like this. So the first thing I'm doing is to look historically and see what land use typically has changed over the years, and just see if there are trends in that. For instance, there are sometimes disturbances that occur. One thing that does occur a lot in the area of the clay belt is there are wildfires. Okay, so is there insect damage? So these kinds of of disturbances, these kinds of trends, then I can use it to model what will still occur when there are changes in the land cover, when there's going to be a conversion from a lot of the forest to the agricultural land. As well, I'm going to be looking at the carbon and greenhouse gases emitted from these land cover changes using different models, and I'll be able to show some of that in the work I'm doing today. And so really, I would say there are two main things that I want to do. The first one is to be able to develop a tool such as farmers are able at any time and practically real time to see what their activities, the effect of their activities in terms of carbon, soil carbon, as well as greenhouse gas emissions. And so having that tool, I believe, will be able to help them to perhaps modify their practices. And secondly, it's to be able to use this information and give advice to the people that are making the land management schemes so that they are always able to have their practices in a way that's sustainable and environmentally friendly. So of course, that will be done in concert with the stakeholders such as the government and the farmers themselves. All right, so here's an example of a simulation I did. I used trees that are predominant in the clay belt area itself, black spruce, eastern larch, balsam poplar, and trembling aspen. And then I performed I simulated rather different disturbances in the area and different ones for the different stands, different tree stands, and just to see what the estimated carbon would be and the greenhouse gas emissions would be from from these activities. And so just looking at the charts, and I'll start with the one at the left. So we can see one of the examples looking at the trembling aspen and also the larch. So I had introduced a wildfire that would happen for all of them. And then in year 25, I had said, well, with the trembling aspen would have insect disturbance, and with the larch, there would be fire and salvage. And so we can see at the 25-year mark, we can see that there's a drastic drop in the biomass over here. However, what was interesting is you can see that the trembling aspen actually over time had more carbon than how the larch recovered in that area. Also observed from the simulation just at the bottom, you can see that over time, the trembling aspen and the balsam poplar were the species that acted as a carbon sink for the most amount of time during the time that was simulated. As well, we can see that the dead organic matter, it was somehow similar. However, the trembling aspen did have the most in terms of dead organic matter within the simulation period. And so at the beginning of the simulation, only the dead organic matter pools had carbon because the forest wasn't yet, the area wasn't yet forested. But then the biomass carbon would start increasing as the trees are growing, then you have more of that. But when it's harvested, of course, you're taking away the carbon, you're taking away things from the area. And so there will be a reduction in the carbon amount. But then after the slash and burn, if there are dead stems and branches and everything that remain on the ground, then of course that's going to go into the dead organic matter pool and increase that pool. And so that's why we would see that increase in the graphs of the dead organic matter, and that is also staying on the ground. So these are just some of the things that occur in the clay belt area right now, and we could say that we can project will also be occurring as land conversions are made. Again, an example here is given in the middle of the salvage logging that's done. So salvage logging does make carbon leave the ecosystem. And then when there's something like an insect disturbance, like one of the disturbances I modeled earlier, that would also cause dead organic matter to stay in the ecosystem. And so that's where you would have an increase in the carbon at that point, and perhaps with the greenhouse gases present. And so this is just an illustration of how land cover and land use changes do affect the carbon amounts that are present in the ecosystem. And that's why I'm trying to do this research, to be able to quantify such things for the land conversions that are expected in the future. All right, so this is just showing you a few examples of where we get this carbon and greenhouse gases that we've been talking about. Where do they come from? So carbon, of course, does come from things like anthropogenic uses, like activities, I would say. like burning fossil fuels or farming, land use changes, and as well from the natural carbon cycle. And we do have greenhouse gases that do occur from our farming activities, for instance, nitrous oxide, methane, and carbon dioxide. And I just threw in this stat because I found it quite interesting doing the research from a few years ago, that methane actually has 23 times the heat trapping capability of carbon dioxide. And someone say, but we always talk about carbon dioxide as the main greenhouse gas. And yes, it is the most abundant, but we also see that there is the danger also from methane. And so that's why it's good to track all these gases as well in the course of our research. All right, so in conclusion, I just wanted to make some of these statements that apart from livestock farming, such as beef and dairy cows, there does exist an extensive agricultural industry with farms of barley, oat, and wheat crops in the Great Clay Belt area. And commercial tree harvesting is also conducted, so we can take advantage of the large and quality trees in the boreal forest region, and that is being done. And with the warming effects of climate change, it's expected that there will be even more clearing of forests as they are converted to agricultural land. And so in my research, we're going to continue to estimate the associated carbon fluxes from the land use activities. And we intend to make recommendations on appropriate land management schemes, which will keep the greenhouse gas emissions to a minimum. And these are some of the references I used, and these are actually the sponsors for my research. So I just want to say thank you so much for this opportunity to share my research with you. Thank you also for giving me an opportunity to talk about the work in the context of the challenges and the changes and the crises that are occurring in Canada. And of course, I will be open to any questions afterwards. Thank you.